Hello, welcome everyone to the International Space Federation members Unified Science webinar. I'm William Brown. I'm one of the researchers at the ISF. I'm sure many of you joining are probably familiar with some of the work that I've done with the team, with the organization here. I've been collaborating with Nassim Haramein for over the better part of a decade now. So, if you've been following our work at all, you've probably heard me speak on more than a few occasions on some of the research that we're doing. I'd like to thank you all for joining this session. It's so great to have you with us. A few things about this session. It is I'm going to be reviewing some of the most recent research that we're doing here, but also we're going to have the opportunity to have some Q&A dialogue. And This Q&A, I'd like to open it up to have a general discussion. So, I'll be speaking about a very specific topic, but I'm always welcome to any kind of question related to our research and unified science in general that you might be curious about or wanted to discuss. In that regard, there is the Q&A field. So you should be able to find the Q&A box where you can enter in a question, and I'll look at that for our Q&A part of this session. Now, there's also the chat, and if you see me looking around, that's because I'm looking for the controls that allows me to enable the chat. Because one of the things is when I start this up, it has a default where nobody can enter in the chat. It's a feature of Zoom, I guess. I don't know. But so I'm going to, while I'm talking, see if I can multitask and enable the chat so that we can all say hello, and I can also kind of see in real time uh, feedback. So, right now, I'm assuming everybody can see and hear me just fine, but without the chat enabled, I don't know for sure because I can't see your comments directly. So, I've enabled the chat, so now you have my full attention. And so, yep, I see people saying hello and where they're coming in from. Let's see, Belgium, Austria, Frankfurt, Germany. I was just in Germany. I was just in Berlin. There was a conference on mitochondria, targeting mitochondria, and it was just such a wonderful, beautiful experience. It was my first time in Berlin, first time in Germany, and it was just so wonderful. I loved it, and especially the conference, which was all on mitochondria, which is one of our particular interests here, which is why I was attending this conference. And actually, I'll be, if all goes according to plan, speaking a little bit on mitochondria and how some of our most recent work is shedding some really interesting insight into some of the mechanisms involved in ATP biosynthesis in the mitochondria, and potentially how we might be able to augment that with resonance and coherence. Okay, yeah, so people are also saying they can hear me just fine. So, so it looks like all systems are nominal. We're good to go here. Yeah, so I'm kind of amazed how quickly this is come up, it was, I guess, a couple months ago that I had my opportunity to speak with you all on one of these webinar sessions. I enjoy it so much. I love it. But this I'm just amazed that we're come around again so quickly. We're here again, and so I was thinking, what would be most interesting to share with you all on the research that we've been doing, and I was thinking, what better thing to share than an exclusive premiere of our most recent paper. So, uh, if you're a member of the ISF and you're decided to join in on today's session, then you're one of the first people outside of this lab that I'm in right now, here in France, to see one of our most recent papers. This isn't going to be a polished presentation. It's one of a paper that was just completed fairly recently, and so I'll be just kind of going over the paper. You're going to get to see it. It's the paper itself in this talk, and a lot of you are probably already familiar with some of the concepts that are foundational to this paper, to this research, because I have talked about some of it previously. That is the cross-scale resonance mechanism. And that actually brings me to the name of the paper itself. Let's see, I have it here. I can go ahead and show you. This is our most recent paper. And so you've already probably heard me speak about, to some extent, the cross-scale resonance coupling mechanism we've been investigating, and hence the name of this paper, From Vacuum Oscillations to Molecular Coherence. So some of you are probably already familiar with some of the background behind this paper, the theoretical development behind this paper. But one of the things is that in this study, we are focused particularly on water, coherent water as a medium of quantum self-organization. And so this paper will be uh, published in a proceedings, the proceedings of the Aquaphotomics Conference that we recently presented some of this information at the University of Kobe in Japan. And so the it's probably next year that the published paper will actually be available to download and view, but we're going to make a preprint available ahead of that. So hopefully in the next few months here, we'll have a preprint that you can download this paper before the actual publication. So, I think there's probably like three main things that I want to get across in discussing this most recent study. And one is the role of water as an organizational medium, not only in the function of the living system. So how our bodies are functioning at the cellular and molecular level, but even at the like larger question of how water enables the emergence of this amazing order of an organization of matter. So, water at the root of the emergence of life. So how the universe is generating this living system, and one of the ways that that is being done is via water acting as a intermediary system between the uh, almost infinite low entropy of the quantum electromagnetic vacuum state at like the Planck density and macroscopic scale, macroscopic systems. So even at like the molecular scale. So how is it driving molecules into taking these extremely or highly ordered phases, highly ordered organizational structures that are foundational to the cell, to the living system. And one of the ways that that is happening is via coupling with the almost infinite low entropy and extremely high energy density of the quantum electromagnetic vacuum. So that's one of the key things that emerges from this study, from this paper. Then also how this cross-scale resonance, this coupling from the quantum high coherence of the quantum electromagnetic vacuum, high coherence regions of the quantum electromagnetic vacuum, how that can drive things like the energy dynamics of the cell, particularly with a focus in mitochondria. So that's one of the things that I'm hoping to touch on in this talk. But then going even more generally, not just on water, because although water is kind of like the quintessential medium that is enabling this uh, coupling, this intermediary function between high coherence phases of the quantum electromagnetic vacuum and molecular organization and cellular organization. It's not just water that is doing that. It's the quintessential example, as we'll see in this paper. But there are other very important systems that, again, you find in biology that are acting as this intermediary. And so we'll look at a more generalized case of that and how it relates to consciousness. And so that's also some of the work that we're doing now. Now that we've got this paper that's focused, that's elucidating some of the key quantum behaviors of water. Now we're looking at uh, consciousness and applying some of these principles to consciousness. So that's another really important things that this study does is it's taking the things that were discovered that were shared in some of the more recent publications like The Origin of Mass and Nature of Gravity, and we're seeing how those discoveries, how the understanding that is revealed in those papers can be applied across scale to larger systems like the molecular and cellular system of biology. Okay, so those with those objectives in mind, let's see how well I can do in the time allotted to us here. So this was a joint study with the whole research group here, Dr. Alriol, Guillermo Bray, of course, Haramein, myself. We propose a cross-scale resonance framework in which quantum vacuum fluctuations are the source of energy driving material oscillators from micro to macro scales, augmenting collective behaviors via increased coherent phase synchronization and strengthened dipolar correlations. So what that's saying is that the source of collective behaviors that is probably one of the key characterizations of the molecular molecular organization of matter in the living system is being driven by high coherence phases of the quantum electromagnetic vacuum in what is called coupling. And one of the ways that that happens is via things like strengthened dipolar correlations. So one of the key ways that you have this energy and information flux from the quantum electromagnetic vacuum, high coherence phases of the quantum electromagnetic vacuum into molecular organization is via polarizable molecules that have dipole moments. And this kind of stands to reason because when we characterize the uh, Planck scale quantum electromagnetic vacuum, we're talking about a Planck plasma, which is comprised of dipole quantum harmonic oscillators. So in this view, the vacuum field supplies a universal restoring interaction characterized by a Planck origin spring constant. So I think many of you have already heard me talk about our discovery of the Planck spring constant, Planck coupling constant. So I'll go into a little bit more detail on precisely what that is. But one of the things that we find is that when you're talking about the formation of dipoles and these oscillations of dipole moments, so these quantum harmonic oscillators or even just harmonic oscillator systems that are, again, very important in biology. One of the things is that these oscillations are not just magically occurring. There is a restoring interaction that is coming from an energy flux from the quantum vacuum. So that's one of the key ways that the coherent modes of vacuum oscillations are driving molecular coherence. So, uh, material systems are therefore modeled as nested coupled harmonic oscillators whose effective stiffness and intrinsic frequencies emerge from quantum vacuum fluctuation driven coupling across discrete scaling domains. So we're also uh, what we're seeing is that none of these oscillatory systems are taken in isolation. In fact, almost in every case, what you're talking about is a system of nested oscillators, like matryoshka Russian dolls. And interestingly, you have small quantum harmonic oscillators that have a high oscillation rate. And what they're able to do is couple to larger oscillatory systems and transfer some of their high frequency oscillations, i.e., energy, into the ground state modes of these larger oscillators and drive them, providing some activation in their ground state that drives the oscillation, and that this is occurring with in this hierarchical fashion with these nested oscillators, almost like a polyatomic nested time crystal. And so that begins to become the description of the living system, of the biological system, this nested time crystal, sourced with its energy, with its oscillation energy in the quantum electromagnetic vacuum. So we derive conditions under which cross-scale resonance arises when normal modes at a given scale are harmonically related to components of the vacuum spectrum and to modes at adjacent scales. Quantum vacuum fluctuations act as a broadband pump that selectively reinforces those modes through polarization, field polarization feedback. And this is one of the key mechanisms that I feel we need to highlight, that it comes from this study and from some of the most recent uh, um, investigations that we've been doing to better understand the coupling of uh, these kind of polarizable oscillatory systems to coherent modes of quantum vacuum fluctuation. Uh, this has a really significant um, influence in or even a really key significance in understanding the organization that was driving the organization of the biological system, but this uh, polarization, field polarization, feedback mechanism also has uh, a very uh, powerful ability to enable us to understand some of the key mechanisms of energy harvesting from the quantum electromagnetic vacuum outside of just the biological context. So we're seeing how this mechanism is important for driving molecular and cellular organization via coupling with the quantum electromagnetic vacuum. But that has some really significant uh, applications outside of the biological system into how you can draw energy from the quantum electromagnetic vacuum. So this is a key principle, and it's presented almost for the first time in this study. So that's a really exciting thing that I wanted to highlight there. So where the quantum vacuum fluctuations act as a broadband pump that selectively reinforces particular modes through this polarization, field interaction, polarization feedback, and I'll give some specific examples that are in this paper to help you understand exactly what's being said there. So we employ liquid water as the primary case study, particularly because it's the quintessential material, I believe, that exhibits this effect, which is why it's at the basis of life and the organization of matter in the universe that we call the living system, the most complex organization of matter in the universe. So the OH vibrational manifold with particular leverage of the what's called the anti-symmetric stretch mode, provides a receptive channel for this quantum vacuum fluctuation mediated gain, this effect here of polarization, field polarization feedback, strengthening hydrogen bond networks and stabilizing coherence domains, especially in interfacial and nano-confined environments relevant to biology. So this positions water as a quantum medium that transduces vacuum-seated coherence into functional organization central to life, with implications for proton conduction, chemiosmosis. That's going to be very significant in the mitochondria, hydration shell dynamics, and cytoskeletal electromechanics. This is going to be very significant in molecular level of consciousness and brain dynamics. So one of the things is stabilizing these coherence domains. And so that is something that is of particular significance here because what we're looking at is um, a, a very important understanding and even almost redefinition of what we're talking about with liquid water. Because you kind of have the conventional view of liquid water, and this is showing all the water molecules in these kind of random orientations. This is a paper by uh, Paulo Renate and Pierre Madel. We actually met with Dr. Renati at Kobe University in Japan. So we got to speak with him directly about this work, this paper. He visited the lab here too because he's based in Italy, so not too far from where we're at here. But one of the key things is the understanding that's emerging about a quantum understanding of water, understanding water as a quantum material, where sure it has this kind of disordered phase, but one of the key characteristics, what they call a quantum field theory, quantum electrodynamic two-fluid coherent picture, is that water forms these coherent domains. That's what's being depicted here with these blue spheres. And it's interspersed with some of these disorganized phases. So it's a two-phase liquid. But these coherent domains here are highly significant because they function essentially as a negentropic converter. So when water is forming these high coherence domains, where the dipole moments of the water molecules are actually being strongly spatially correlated, and they're lining up, that's where you begin to get strong coupling with the quantum vacuum, uh, and coupling that is driving high coherence. So it's forming, it's driving the vacuum into high coherence organizations. So with strong correlation among the quantum harmonic oscillators that make up the quantum electromagnetic vacuum. So I think most of you know the terminology for that is the Planck spherical unit. And so it's driving high coherence of that, and then that in turn is driving high coherence of the water molecules, and you get this feedback cycle. And the high energy, low entropy of the quantum vacuum is being drawn through the water. Hence, it's these coherence domains are functioning as a negentropic converter. So in most material systems where you have an increase in entropy, water is counteracting that via coupling with the quantum electromagnetic vacuum. And I have within the paper here, we have a depiction of this mechanism. So where you have so broadband quantum vacuum fluctuations of the electromagnetic field. So broadband just means that there are many different modes, i.e., wavelengths, frequencies of the zero point energy oscillations of the uh, quantum electromagnetic vacuum, that is zero point field. And some of these modes, so there's a broad range of the spectrum. Some of these modes interact very specifically with the dipole modes of water. So water has, with the OH bond, many different kinds of ways that it can vibrate and stretch. And so what one of the more particular ones, important ones, is the OH stretch mode. So the stretch or vibration of the oxygen hydrogen bond. And it can have a symmetric stretch or an anti-symmetric stretch where the two hydrogen moieties are oscillating not in tandem, but kind of in a anti-correlated fashion. That drives a strong dipole moment of the water molecule. But if that frequency of oscillation is coupling to one of the modes of this broadband quantum vacuum fluctuation pump, it's going to couple. You're going to have a resonant interaction there, and it's going to become potentially locked, where when there's a push in the OH stretch mode, the coupling with the quantum vacuum corresponding quantum vacuum fluctuation mode is going to boost that push so that they're in phase. And when there's a pull, when it's coming back, it's going to have the same phase relationship. And that's called phase locking. It's like a child on a swing. If you're phase locked, you're pushing when they're going out and not when they're coming in, so that because otherwise that's not well correlated. It's not in resonance, but so it's a resonant interaction, and it's boosting that OH mode, that OH vibrational energy, and that's increasing the dipolar correlation among water molecules. and that's driving the formation of these coherence domains, the highly organized water structures. So uh, um, when you have these high coherence domains, this is a region where the water has become strongly coupled to the quantum high coherence phases of the quantum electromagnetic vacuum. And it's getting this energy flux that's augmenting the dipole moment and increasing the correlation among these structures. So the question then is, uh, okay, so I see, how does the water become coherent? So the water is becoming coherent via interaction with that broadband uh, quantum vacuum electromagnetic energy fluctuations. So there's many different frequencies, many different wavelengths of that quantum electromagnetic vacuum fluctuation. And there are particular frequencies that are at a harmonic of the OH stretch mode of water, of the water molecule. So when there's a match there, there's a resonance coupling, and it can become phase locked. And we believe that that's one of the primary mechanisms by which you get this high coherence phase of the water is via phase locked coupling with uh, these harmonic modes of this zero point field. That's when you get this energy flux. Uh, and when you get that kind of energy being contributed into the OH stretch mode of the water molecule or any polarizable molecule, but we're focusing on water here, that's going to strengthen the dipole moment. When it strengthens the dipole moment, the water molecules interact more strongly, and there's a stronger interaction between them. Now, that's going to drive them to lock into these geometrically ordered configurations. That's, you could say, structured water. Now it's still a liquid, so it's highly dynamic, more like a liquid crystalline structure. But you get this kind of entrainment where it's being where these oscillatory modes are being phase locked with 0 point energy, and that's counteracting a what would normally be an increase in entropy, i.e., you've got water and you've got like thermal agitation, which should drive randomness and disorder, and so that it's not well correlated, so that it's becoming decoherent. But you have it being counteracted via this phase lock coupling with the quantum vacuum, which is supplying via resonance, via this resonant match, this resonant interaction. It's supplying coherence, supplying neg entropy, counteracting the normal increase in entropy. And hence, water becomes a negentropic converter. And so, one of the ways that we can see that even quantitatively is via the correlation functions. To understand this cross-scale resonance mechanism, we can imagine the quantum electromagnetic vacuum as a broadband pump, specific modes near or harmonically related to an intrinsic material frequency. So this is generally almost any polarizable molecule. The stretch mode of the water OH bond is the example we're looking at here, is selectively reinforced, and that's via a feedback in the medium. The quantum electromagnetic vacuum is increasing the polarization of the dipole moment, which is driving for polarization of the field. It's driving further coherence of for instance, the quantum vacuum fluctuations, which is then via this like feedback mechanism driving greater polarization of the medium. And so you get a transition from this like disordered phase to a more ordered configuration. And so in the origin of mass and nature of gravity, we analyzed the coherence of the electromagnetic field within a proton-sized cavity resonator and found that the quantum vacuum fluctuations are described by a symmetrically ordered correlation function. The coherence of quantum vacuum fluctuations results in a non-zero expectation value of the energy density of the field. And so that we can see here from the origin of mass and nature of gravity. And this is our correlation functions. And it results in a non-zero energy expectation value of the vacuum. This is the quantum vacuum energy density of the electromagnetic field, rho vac, which without the Planck scale cutoff is an infinite energy density because of this broadband nature of the 0 point energy. If it has modes at every conceivable frequency, it has an infinite energy density. But one of the things that we see from these um, correlation functions is that it decomposes into the thermal component, which is the Bekenstein uh, um, component. I'm sorry, the Boltzmann constant, a thermodynamic relationship, uh, and the 0 point energy component. And so um, the ZPE spectrum, furnishing a broadband pump, persists at as the temperature goes to zero. You have the 0 point energy contribution, and we see in the origin of mass and nature of gravity that with these correlation functions and the broadband pump hypothesis, that the ZPE term, even as temperature goes to zero, where you have this 0 point energy term, uh, it's acting as a pump. And the oscillator equation with ZPE acting as a source term shows why dipoles don't decay but can lock to the field. So that was one of the key things that we saw from the origin of mass and the nature of gravity is why don't atomic resonators, atomic oscillators decay? So like the electron cloud around the nucleus. Why doesn't the electron crash into the nucleus? It's because there's a ZPE term that's constantly providing energy. Well, so we're now taking that foundational understanding from the origin of mass, nature of gravity, and going beyond just the atom, just beyond the hydrogen, proton electron configuration, and we're seeing that you have the same dynamic in, for instance, water and the OH stretch mode, so that uh, there is now a source energy, a ZPE contribution in a coupled medium like liquid water that via this feedback reinforced loop, the polarization modifies the field correlations and in turn drive further polarization so that resonant molecular modes, that OH stretch mode, are selectively reinforced and can synchronize across many oscillators. So the oscillation of the water molecule here, the OH stretch mode, that's determining the intermolecular interaction. So here's one water molecule and another. This is actually forming a dimer, a water dimer. And this actually has a name. This is the Eigen and Zundel cation motif. You can see here that this isn't just simple H2O. In fact, here we're talking about a hydronium ion, H3O plus OH. So you know, a highly electrodynamic active medium here via this energy contribution from the quantum vacuum from the ZPE energy. And this isn't just magically, this oscillation isn't just magically being sustained and occurring. It's happening via coupling with the quantum electromagnetic vacuum. And so one of the things that we can imagine, what we can consider, is at the um, origins, the beginnings of the emergence of the living system. Uh, One of the things that we can see that uh, the is occurring. Uh, Let me get actually this portion in a slideshow mode. Um, One of the things that we can see is that the universe is doing. So let me see here. So what is the universe doing? One of the things that the universe is doing, that we're going to zoom out a little bit here, is that it is making living systems. So uh, within the universe, you have these interstellar nebula. And what's found is that they are chock full of not only star forming regions that are also forming planetary systems. Uh, and these star forming regions are forming complex multi-nucleon elements like carbon, oxygen, and the multi-nucleon elements central to life. But these large gas clouds here, interstellar nebula, are chock full of biomolecule or organic compounds, I should say. And so one of the things that the universe is doing, so like high amounts of like this phosphate containing molecule have been found, these interstellar nebula that forms one of the primary components of DNA. One of the things that uh, the universe is doing is creating these abundant organic molecules, and these regions are generating. Some of them have been measured to generate like 75 times the amount of water on Earth every day. So vast amounts of water. And so what we can see, and from this study where we're seeing how quantum vacuum uh, coupling with high coherence modes is driving molecular organization, is we can understand that in these regions where you have like liquid and ice water forming these clathrates with polycyclic aromatic hydrocarbon molecules, that the water that's forming these coherence domains and acting as the negentropic converter is the primary driver that is causing this molecular organization, driving the ordering of these molecules in interstellar space into highly complex organic molecules, such that our coherence domain here is the primary intermediary between the extremely abundant low entropy of the quantum electromagnetic vacuum and high energy uh, and molecular organization. So, water is central to forming the precursors to life, to the biological system. So, where you have this high abundance of water and the molecular precursors, the interaction between these two is driving the formation of the first cellular systems. And water is at the core of this coupling between quantum vacuum structure and molecular coherence. And then so this early material coming down, raining onto like a primordial earth. And again, uh, of key importance is you have these areas where you have water, and water is driving the formation of life. So how matter in the universe is going from a proton, electron, plasma, simple single proton matter, and within a few billion years, it's being driven into this complex ordering that is the foundation for life. And so, water and its ability to form these coherence domains is what is driving the organization of life, not only the emergence of life, as was depicted in the previous slides there, but even in extant living organisms today, like ourselves, water is the key intermediary. So this is showing, for instance, hydration shells. This is water around protein, and it is the interaction with the water that is determining the structure and hence the function of this biomolecule, which is the workhorse, the enzyme of the biological system of the cell. Here with DNA, this is a close-up look at water forming this chiral heterogeneous superstructure around the DNA, and it's the water that is holding its structure and hence its function. So the uh, way that water is forming these coherence domains via coupling with the quantum electromagnetic vacuum is key to understanding biological organization and even the emergence of life to begin with. So now going back to the paper, um, because I'm realizing time is going by much more quicker than I anticipated on getting through some of this. Let's get to some of the uh, mathematics here to really see how this isn't just hypothesis, but actually we can see its validity mathematically. So, again, from the previous publication, The Origin of Mass and Nature of Gravity, we saw the introduction of the Planck spherical unit and how the PSU is a fundamental oscillatory perturbation of spacetime resulting from quantum vacuum fluctuations. And what we're going to see in this paper is how it is the fundamental basis from which we extrapolate out to macroscopic oscillatory systems, which are ordered ensembles of PSUs. Indeed, it must be understood that all material systems are composed of these fundamental discretized spacetime spherical oscillators, and it is only in the hierarchical structure of phase transitions from high coherence to low coherence that distinguishes material density, defining a gradient from empty space to matter. So, when we're talking about material oscillators that are central to the form and function of the biological system, we're talking about just highly organized phases of discretized uh, spacetime, Planck spherical units. And so we can define the oscillatory behavior of the Planck spherical unit. So the fundamental spacetime voxel PSU is an oscillator with a characteristic pulsation that is defined by Planck constants. Here, just taking the speed of light over the Planck length. And that corresponds to the pulsation resulting from the Planck force or the gravitational restoring force between two orbiting PSUs at a Planck distance of 1. So this is, in a certain sense, the first level of organization, the first level of how we can see this resonant, cross-scale resonant interaction uh, being what is driving collective coherent uh, phases of organization of really discretized space-time. But if you go out in scale, you're just starting to talk about molecular systems and then cellular systems and then living beings or stars or planets, if you will. But one of the key things that we can see from our first collective system, two interacting Planck spherical units, is that we have the Planck force here, and the Planck force over the distance of a Planck length, that's the distance separating two PSUs that are interacting, gives us a force over a distance, which is a coupling constant. And hence we get the Planck coupling constant, which is the force of interaction between our first collective system, coherent collective system of, in this case, two interacting PSUs. And so that gives us our Planck coupling constant, which interestingly is just the Planck force over the distance of a two of a Planck distance. And so I'm kind of assuming that many are familiar with the Planck force. Just a quick refresher, if you're not, um, if we come here to the origin, mass, nature, gravity, or the more recent one, uh, completing Einstein-Rosen's geometric vision of unity, we can see how this is the Planck force here at the root of all forces. So this is the unified force. The color force, the residual strong force, Newtonian gravity, they all emerge via screening mechanisms from a metric screening across the space-time curvature, the horizon of a black hole, a microscopic black hole. All these forces originate from the strong force. And here we're seeing us generating this coupling constant. And the interesting thing is that when we put that coupling constant uh, into, for instance, the um, uh, um, uh, it- uh, it, um, region of or into a Planck mass with this screening factor of alpha G, it outputs very precisely the frequency of the uh, strong interaction, the residual strong force. So we can also derive this residual strong force from the Planck coupling constant, which is describing the interaction between the strong force across the metric curvature of the proton charge radius, uh, and it's outputting the typical frequency or oscillation of a proton. So now we have this generalized equation defining oscillatory systems and a material oscillator, resonator. Uh, and we see for the proton, it outputs a value very specifically. But the thing that we've discovered is that we can input any mass here, and it'll output the precise frequency of the system that we're looking at via this generalized equation right here. So, as an example, here we can put in the mass of an alpha particle, which is helium. So you go from proton hydrogen nucleus to a helium nucleus, put in the mass there, and we get out this very specific frequency, which is actually found uh, in other methods of computing collective excitations in nuclei. So via this generalized equation here, we output almost exactly the textbook value for the giant resonance, the resonance of the nucleus of a helium nuclei via this generalized equation here. So this value, 3.1 times 10 to the 13 hertz, we find it is the same value you get from this textbook, Collective Excitations in Nuclei. Let me see if I should read this. I don't know if that's uh, essential to understanding what we've done here, but the Planck pulse frequency is a characterization of the vibrational energy value of the alpha particle oscillator and other resonators coupled across scale via the Planck plasma coupling constant, which is screened when scaling from the PSU fundamental oscillator to larger systems. So now we can go and look at what happens when we input that value for water. Now, we take the mass of a water molecule and using that same generalized equation with the Planck coupling constant, we output a value 1.49 times 10 to the 13 hertz, which is within the range for the measured value of OH and hydrogen bond vibrational modes for water in a strong hydrogen bonding environment with measured absorption spectra. Which so if you go and you measure water in its liquid phase, particularly in like a strong hydrogen bonding environment, it's between 1.35 times 10 to the 13 to 3 times 10 to the 13 hertz. And so our value computed from the Planck coupling constant falls right in that range. So one of the things is that this is showing it's a strong indicator that that OH vibrational mode that is measured is a result of the collective action of the PSU ensembles that comprise the water molecule and coupling with the quantum vacuum electromagnetic energy density and this polarization feedback mechanism. So the OH stretch mode, which is determining to a strong degree the hydrogen bonding network of water, which is forming those coherence domains, which is key to the emergence of life and the operation of extant living systems. It's being driven by the vacuum coherent modes of quantum vacuum fluctuations. And then, so there's other presentations that I've done that you can see that we do this across scale. So going from single atomic nuclei to molecules to macromolecular systems, like the microtubules here, and even up to whole cells. See, I have our table here, and we have the references where the measured values for each one of these systems can be looked at and seen that it is, if not precisely identical, it's very close to our computed value or predicted value based on coupling to the quantum electromagnetic vacuum. And we're going from the Planck spherical unit, which actually defines the Planck coupling constant, all the way up to pyramidal neurons. And so um, one of the things that is significant about that is that in terms of its effect on driving water, what we can see is that so this framework clarifies why water's amphoteric chemistry matters. That is in regards to water's ability to act both as a acid and a base. So its ability to share protons essentially, uh, or electrons. Protonic motifs such as the eigen-Zundel cations. That's the first figure I was showing there. Those are showing eigen cation, which just forms that H3O plus motif. Uh, Provide dynamic hubs where OH vibrations driven by ZPE, hydrogen bond topology and proton transfers are tightly intertwined. If the OH antisymmetric stretch is selectively energized by the vacuum pump, the resulting increase in correlated dipolar activity can facilitate barrier crossing along hydrogen bond wires. So passing protons through the hydrogen bond network of dynamically ordered water, liquid crystalline water, thereby supporting established proton hopping routes, the growth type dynamics. In biological settings, the same reasoning naturally extends to structured aqueous phases at functional interfaces. For example, mitochondrial proton circuits, where small phase-consistent vibrational biases uh, may yield outsized transport effects. So, phase lock resonant boosting of the OH vibrational mode that's driving strong hydrogen bonding, increasing proton transfer along these mitochondrial proton circuits has potentially outsized transport effects, even if the energy input from the quantum vacuum is minimal. So further investigations into quantum vacuum fluctuation coupled augmentation of highly coordinated proton transport in the mitochondrial intermembrane lumen may reveal a quantum coherent energy source directly contributing to ATP synthase activity, illuminating a fundamental quantum biophysical basis for the biosynthesis of cellular energy. So here, what we're saying is that within the mitochondria, this is the mitochondrial inner membrane space where you have the ATP synthase machinery that are generating ATP, which is the energy molecule of the cell. These little red dots are protons, and the way that these are being channeled, they're forming proton circuits, proton wires, and it's the water via this cation motif that is forming the wire that's the conduction channel for these protons. And if that's being augmented via phase lock resonant contribution from the quantum from coherence phases or this polarization feedback mechanism with the quantum electromagnetic vacuum, part of the energy that's being derived or generated by the cell is coming from the quantum vacuum energy from ZPE. That's a key finding from this study. Now, one final thing, because I have gone over time, I was trying to be as succinct as possible, but this is the first time I've presented this paper. So, this is the exclusive premiere of this paper. So, I'm actually kind of getting an idea of how much time I need to get through some of these ideas here. And I kind of underestimated the amount of time to get some of these key points out. But one of the important things to finish here is the pyramidal neuron. We're seeing that you enter in the mass of pyramidal neuron into our function here, and it outputs 80 hertz. 80 hertz is the gamma oscillation, the gamma frequency. And so Uh, One of the direct applications of this is in consciousness because the gamma oscillation is also called like the binding oscillation. It's what is thought to be so significant for consciousness as far as the neural correlates of consciousness go. So we're beginning to see how the brain acts as a resonant antenna in the quantum electromagnetic field. This is beginning to elucidate that so that we can see that the neuronal correlates, how it's having that field-like antenna resonant behavior. Well, that collective activity of pyramidal neurons that is thought to um, be one of the key mechanisms of binding. That is how consciousness is forming a seamless, continuous whole, even though you've got ostensibly many different kind of sensory inputs. You've got like shape and color. How is the brain putting those together correctly so that, if you've got a sphere and you've got red, the brain is able to bind that together as a red ball. That's a phenomena. That's a qualia of consciousness, and uh, the gamma oscillation is thought to be one of the neural correlates of that kind of binding aspect of consciousness that uh, unites sensory information into a seamless, continuous whole, and not its independent units. One of the things, this is having direct insights into the nature of consciousness, and so uh, some of our most recent work, something that I'm working on even right now, is we can look at what happens when we adjust some of the um, uh, dipole strength of these oscillatory systems in the pyramidal neurons. So when gamma oscillations, the 40 to 80 hertz synchronized neural firing, they phase lock the magnetic fields of distributed bound neurotransmitters. And one of the things also that we're currently looking at, so you're getting bleeding edge research right now, is many of the neurotransmitters are themselves these uh, aromatic moieties, these aromatic molecules, which also are very important because you can see here we looked at specifically like tryptophan. That's one of these aromatic molecules, and many of the neurotransmitters that are driving the behavior of these pyramidal neurons are derived from tryptophan, and we output its dipole oscillation, which is also going to be important in its magnetic field, its magnetic properties. And so, like, one of the things that we can imagine is that via coupling with the quantum electromagnetic vacuum energy density, you could have like entanglement or quantum tunneling mediated transfer of some of that low entropy, high energy density at the core, Planck energy density, quantum tunneling some of that electromagnetic energy density through the induced magnetic field of some of these neurotransmitters, generating gravitational wave behavior. Looking at the um, uh, magnetic field interaction, these oscillatory molecules. So uh, with that 80 hertz gamma synchronization, they phase lock the magnetic fields of distributed bound neurotransmitters, creating a unified magnetic field network that could physically instantiate the feature of binding, solving how distributed neural representations are unified into coherent conscious experience. And so we can actually run a simulation here where we're looking at a particular receptor density with these vacuum driven oscillations, and we can run a simulation. And if you can see these yellow lines, that's where these neural receptors of pyramidal neurons are becoming, their activity is being strongly correlated, i.e., entangled, via this unified magnetic field network driven from quantum vacuum energy flux. Now, it's actually a very low amount of entanglement here, but if we increase the receptor density, so going up to 300, we can see actually a high density of entanglement amongst these neuronal receptors, so that entangled receptor pairs can exhibit instantaneous correlations where it's quasi-instantaneous correlations where when one is perturbed, its entangled partner responds immediately, regardless of distance, and this could enable non-local information integration across the synaptic network. And all of this is being driven by the Planck coupling constant from our polarization feedback mechanism and energy flux potentially interacting with the dipolar induction of magnetic fields in neurotransmitters. All of this is starting to come together in a very interesting and exciting picture that's directly tying the neural correlates of consciousness to quantum vacuum fluctuations. Yeah, I'll have to leave it there for now, but I think I achieved the primary objectives. So showing how water forming these coherence domains is central to its function as intermediary, coupling with coherent modes of the quantum vacuum fluctuations, so that it's actually functioning as a veritable negentropic converter, and that neg entropy, counteracting increasing entropy of thermodynamic systems, of material systems, is actually an ordering parameter, so driving molecular organization. And so that's important not only for uh, how we function, how cellular life organizes itself and functions, but even in regards to the origins of life, of the how matter in the universe is forming into this amazingly complex system of the biological entity, but then also the generalizability of understanding this polarization feedback mechanism to harnessing ZPE, because that's what nature is doing. That's how nature is harnessing the ZPE energy. We see that in the quintessential example of the water molecule. Uh, Hence, we can see how it's potentially uh, the quantum mechanics of driving energy biosynthesis in like mitochondria, which is foundational to life, potentially how we can augment that kind of energy production in the cell. And then also, surprisingly, or perhaps not so surprisingly, that this is connecting with consciousness. So we're understanding how the coupling of the biological system to the quantum vacuum is the key mechanism that's going to allow us to understand uh, how the living system is acting as a resonant antenna in the electromagnetic field, and hence being able to um, engender consciousness, channel consciousness from the field into the biological system. Uh, so, uh, with that, it seems like that is just such a brief and small introduction into what's in this study, what's in this paper. But with that, we can see if there's one or two questions I can grab here to look at. Bear with me just for a moment as I look at what questions have come in. Ah, there's an interesting question here from page one. Water is life. For life to emerge, water must be present, correct? That's a question. Uh, or is there any other medium for life? In fact, it was called the 1440 event. This was a really awesome event we had back in 2019 in Northern California. Nassim seemed to suggest life can emerge from other molecules. But so that's a great question, and you are correct that it is possible for life to emerge from systems other than water. So uh, you know we're looking at water in this study, but one of the things that we try to do periodically, even spelling it out in the discussion of the paper, is that while we're looking at water, that this mechanism is generalizable. So um, all material systems are a ensemble of an organization, a collective organization of the discretized space-time at the Planck scale. So we're collective uh, ensembles of Planck spherical units. And so every material system uh, is intrinsically coupled to the quantum vacuum structure, but where it becomes non-trivial. So in a trivial sense, everything is curved spacetime and the electromagnetic energy density. But in a non-trivial sense, some material systems, particularly polarizable systems like water, can have this kind of resonant feedback interaction where it's drawing more energy from the quantum vacuum than other material systems that are not polarizable systems. So it becomes a non-trivial way that the material is drawing excess energy from the quantum electromagnetic vacuum, and that high coherent energy is just like energy from the sun is neg entropy input. It's energy input that counteracts the normal increase in entropy. So water is the probably one of the best materials at having this polarization feedback mechanism, but it's not the only one. So there are other mediums, other liquid mediums, even that life could emerge in, and actually many organic chemists and molecular biologists don't actually believe that I'm sorry, that life emerged first in water because um, in terms of some molecular interactions, water can be quite uh, deleterious because you can see an example of this even with like mummies or yeah, so like how well are ancient remains preserved? If you have something like the high dry um, areas of like the Peruvian Andes, you can have mummies that persist for thousands of years because they're not interacting with water. So one of the things that the water can do is actually break down molecules, and that probably depends on which phase of water we're talking about. Is it in that disorganized phase that water does exist, liquid water does exist in, or is it in that organized high coherence phase? So actually, it can be very difficult for molecules, at least some organic chemists and molecular biologists think this. I don't necessarily agree, but it can be difficult for large macromolecules to form when water is hydrolyzing bonds and with that kind of behavior. So actually, there's a lot some researchers who believe that life may have emerged in hydrocarbon liquids like what you would find on the moon of Titan around Saturn. So, and it's totally conceivable that you can have conditions where there's coupling between a like methane liquid, a hydrocarbon-rich liquid, and the quantum vacuum, and you can have negentropic action or organizational input from the quantum vacuum driving organization of life. Personally, though, I believe that the most reasonable and logical situation where you have the formation of complex organic molecules is in interstellar space in these clathrate water ice interstellar agglomerations in nebula where you have a high input of like ultraviolet radiation is driving molecular dimerization, molecular binding, covalent binding. Actually, a lot of that energy input, it's found that if that's occurring if those are nebula are situated near a black hole, the energy input from the black hole is almost ideal for driving some of the molecular interactions that drive formation of large complex macromolecules. So the input of a macroscopic black hole and the quantum vacuum energy coupling might be just the right kind of mixture in interstellar space to form the precursors to biomolecules. Is coherent water a form of liquid crystal? And it looks like I'm not. You said that one was answered. So yes, yeah. So coherent water is a liquid crystal. And so, that's the primary way, that's the primary phase of water within the cellular system, is as a liquid crystal. And actually, where you have uh, the breakdown of that high coherence phase of decoherence into the more random organizational phases of what's called like bulk water, that's where you oftentimes have disease. So that's a detrimental physiological state of the cell is the breakdown of that liquid crystalline water. Will there be a recording? Yes. So this will be available on YouTube on the ISF SpaceFed YouTube site. Probably give it about a week, and we'll have this processed and uploaded, and so that you can go back and review any of the points from it. So. If you, this is from a good friend, Kat. Hi, Kat. If you're still with us, thank you for the question. If you could see the quantum vacuum, what would you imagine it looks like? And so this is something that I actually really like to do is imagine this. If you could, if you were receptive to the wave-like energy of the quantum vacuum, remember that broadband frequency field of a spectrum of the quantum vacuum, what would it look like? One of the things is that you would lose the illusion of separate things. It's all you look around in the room around you, and you've got like your computer, your laptop, or your phone, and it's like a distinct thing, and there's like this seeming space in between you and it, and it's on a desk, which is another distinct thing. But that's only with the very small electromagnetic region of the electromagnetic spectrum that we're receiving now. You could perceive that wave-like energy at the Planck energy density, you would not see separation between anything. What you would see is sustained patterns of this fluid dynamic. So, double torus-like vorticity type patterns interspersed with more kind of random uh, uh, um, fluid dynamics, and then another highly organized toroidal pattern. But there would be no space at all. It'd be one thing. It would be a continuous fluid with interspersed with high coherence patterns, sustained patterns. And actually, that's the same structure we're describing for water with this framework, is that it's a two-phase liquid where you have highly coherent regions, toroidal regions, coherence domains, interspersed with more randomized organizations, but it's one continuous fluid. And so that's one of the reasons why water is such a quintessential medium that is coupling to the quantum vacuum, because it's kind of like a macro scale version of the Planck scale organization of the quantum electromagnetic vacuum. It's kind of like it's got so many of the same properties. So that's a really interesting correlation there. Okay, so yeah, I probably got to call it there. So we've gone a little bit over our allotted time, and so as much as I would love to discuss these topics with you all further, we'll have to wait until our next session. I'm already looking forward to it. I love getting to present some of this information with you all and share some of these amazing insights that are developing from the research being done here with the team. Thank you again all for joining and bearing with me as we did the premiere of the most recent paper. And we'll have updates of when this paper is going to be available for you to download. Hopefully, be available for you to read in detail if you're so interested. So don't worry, we'll definitely we'll let you know when it's available. And until the next time that we get to have another one of these sessions, may the vacuum be with you. Take care, and I'll look forward to our next session. Bye all.